So, to start off, I have a joke for you. All right, this is a joke that I used to hear as a kid every once in a while. It's about as good as the other joke. Remember the first joke about the cat and the dog? That was pretty good. This one's about that good. Okay, here we go. Ready? What weighs more? A gallon of gold or a gallon of feathers?
Gold.
Okay, so talk to your neighbor about what I just said. See if you can figure out the answer there. Okay, so what'd you decide? What's the answer? What's that? It's not. What's not possible? To have a gallon of feathers? Okay, good. So, if I have a gallon of feathers, it's possible to get a gallon of feathers, right? Or what? Yeah, you get a gallon container and you stuff it full of feathers, right? And then a gallon of gold, you get a gallon and you stuff it full of what?
Silver.
Gold. It's gold. So what did we say? I mean, in that case, which would be heavier? The gold would be heavier, right? So I said the joke wrong, didn't I? Right? How does the joke usually go? What weighs more, a ton of gold or a ton of feathers? Or a pound of gold and a pound of feathers? Right? And I remember as a kid hearing that joke and then hearing somebody say it wrong. Say, they're the same because it's the same amount. I was like, no, that's not how it works, right? So, what weighs more? An atom of gold or an atom of helium? What weighs more, an atom of gold or an atom of helium? What weighs more? Atom of what? Huh? What was the question? Is that what you're saying?
Helium and what?
Gold. What weighs more, an atom of helium or an atom of gold? Well, this isn't a trick, right? The masses of atoms are different from each other. You can't just say I have two atoms, therefore they must weigh the same, right? Where do we learn the mass of those atoms? It's the lower number up there, correct, on the periodic table? All right. And initially, the units for these masses were just units of the lightest element, which was hydrogen. So everything was in terms of how many hydrogens, or they would also say atomic mass units. Okay? So hydrogen was one atomic mass unit. Carbon, how many atomic mass units would carbon be then? We look up there. It's not the 6. The 6 is the number of what? Protons, but the 12. Right, the 12.011. Okay? Good. Now, if I have, we'll see how this pen is here. If I have a little container here, and in here I have hydrogen atoms. All right? And you guys, I handed out some of these little kits that have these little white balls in it. Open up the kits and look, and you'll see the white ones are the hydrogens. Okay? And then I have another container full of red balls. The red balls are the oxygens. Okay, can you see that? Got some reds and whites in there. And if I want to combine hydrogens with oxygens to form water, right? Now, hydrogen generally comes in the form of hydrogen gas and oxygen gas. But to simplify our discussion here, we're just going to say hydrogen atoms and oxygen atoms. And I want to bring them together in this configuration. You see the water molecules in there? Maybe you can make one if there isn't one in there. Yeah, there we go. Looky there. There's a water molecule. You see it? Right? Now let's pretend that the mass of one of those white balls, these are the white ones, let's say that each one of those is 1 gram. All right, 1 gram for that to get 1 ball of that white stuff. And this one here, the red balls, we're going to say is 16 grams per ball. Okay, it's a little bit bigger. You can see 16 for one of those red ones. All right. So, how many grams of the hydrogen do I need to weigh out? And how many grams of the oxygen do I need to weigh out so that I can combine these things together and make water? Now, I can put a 2 here because I see I'm going to need 2 hydrogens for every oxygen, right? Can I also then just say, okay, it looks like I'm going to need twice as many grams of this as I need of that. Is that going to work? Yeah, because we said that each one of these is a gram, but oxygen, each one of these is 16 grams. So I can't just put in a gram of this and 2 grams of that. Can you guys see that? Not quite? Doesn't matter? So how many grams of this do I need? 16. I need 16 grams of oxygen. And how many balls will that give me? 1 ball, right? And I need 2 grams of hydrogen, which will give me how many balls? 2 balls. And then, when I combine those together, I'll get 1 unit of water. And how much will the mass of that water be? 18 grams. Okay? Each atom weighs a different amount to get a single ball, right? And another thing you could think about is, well, yeah, that's good right there. We'll stop right there. So, atoms have different masses, and if you have some material that you can weigh out on a scale, right? And a scale is what chemists use to do their chemistry, right? This is a little picture of a scale. Okay. I have some chemical here in my container, and I have some chemical here, and I need to weigh out different amounts so I can perform a reaction. To identify how much you have to weigh out, right? Let's see, was this just get back here just now? Is this class? Wow, who put it up here? Or did I put it up here? Okay, all right. Anybody else need to sign that? Anyway, okay. So to know how much you have to weigh out, you have to look at the chemical reaction. For example, here's a chemical reaction where I'm going to combine aluminum and chlorine, and I want to form aluminum chloride. What's the chemical formula for aluminum chloride? Talk to your neighbors really quick. Aluminum chloride. Did you guys get it? What is it? Aluminum chloride. Close. AlCl3. That's right. How do we know it's 3? That's right. What? Aluminum is?
Yes.
Aluminum. By losing 3 electrons, it'll have an electron configuration similar to that of neon. Okay. So, there it is. So here's my container of aluminum. And here's my container of chlorine. How many grams of aluminum do I have to weigh out? And how many grams of chlorine do I have to weigh out? If I want to make sure all of it is used, I don't want to have any extra leftovers, to get a unit of this aluminum chloride. Okay? So how much aluminum do I have to weigh out to get a unit of aluminum? Okay, 26.98 about grams of aluminum to get 1 unit of aluminum. How about if I want to get 3 units of chlorine? 35.4 times 3? Is that true? Okay. And if I combine those together, how many units of aluminum chloride will I get? Or sorry, how many grams of that? I'll get 1 unit, that's right. How many grams of that stuff will I get then? Okay, so we'll want our calculators out. We're going to be needing to use our calculators moving forward in this class, so you want to make sure you get a good calculator for yourself. Yeah?
Why was chlorine trying to be neon?
Chlorine is trying to be argon. So it was aluminum that was trying to be neon, they said.
Okay.
So if you look at aluminum, it has 13 electrons. And then you look at the noble gases and see that there's 10, 18, 2, 36, right?
Yeah, okay.
So the one that's closest to aluminum is 10.
I was confused about the chlorine. That's like, I don't know.
Chlorine is closest to argon, that's right. So it wants to have a -1 charge. All right, did anybody get this value here? What's the total mass? 133.18 grams of aluminum chloride, right? That's just the conservation of mass. That's how we did that. Okay? So these are the kinds of questions we can answer now. And it turns out that that number up there, which I told you has units of kind of atomic mass units, right? Carbon is 12 because it's 12 times heavier than hydrogen. We can also put on that unit, we can put on there grams of that material per mole. Grams per mole. Now, per mole, you always don't know what that means. Per molecular unit, or per unit, grams per unit, to get a unit of it. Now, you guys have heard of the word mole before, right? On the test? What's that?
Yeah, on the test.
It talked about it on the test?
Yeah.
Oh no, I'll have to look at that. But the term mole is short for molecular unit. Molecular unit. All right? Now, you guys remember the word molecular? We talked about that before, right? How do we recognize if a compound's molecular? No metals in it, right? That's a molecular compound. How do we, do you guys remember we had a little conversation about what the word molecular was referring to? Similar to the word modular. Do you guys remember what that word means? Kind of goes around in groups. Like water molecules go around in little units like this, little packets like this. Whereas ionic compounds always go around in what? How did we say ionic compounds reside? 3-dimensional lattices. Do you remember that business? Yeah, salt. Salt. Ionic compounds are salts. Now, here's a story. Back in the day, they didn't know that ionic compounds resided in 3-dimensional lattices. They thought they were like water molecules, and that sodium and chlorine just kind of went around in pairs like that. Okay? So because of that, they called everything molecules. And so when they talked about a molecular unit, that was a generic term for anything that they were interested in referring to. So they used the word mole, referring to molecular unit, but gradually they started to differentiate between molecules and ionic compounds, but the term mole never went away.
There's some moles on the exam. Talking about this, that's on the exam.
I don't know. We'll have to take a look. I didn't realize that it said the word mole on there. We'll have to see what problems. We'll see what it says, yeah. We'll see what it says. Yeah, so we'll go take a look at it and see. Yeah, we won't talk about it in here, but everybody can take the question and take the test, and we'll see if it influences the ability to perform on that test, on that question. Okay, so molecular unit, right, can refer to a molecular unit of an element or the molecular unit of a compound, okay? And don't get bothered if we call this a molecular unit. I mean, we're not going to call it a molecular unit. We're going to call it a mole, but we'll just forget for a while that mole means molecular unit, and we'll just say it's what we call it, okay? So a mole. Now, what that does for us, again, is it allows us to identify how many grams we need to perform the chemical reactions we want to perform. So initially, hydrogen was identified as 1 unit because it was the lightest, but eventually we decided to call carbon 12 units because it was the most abundant and most easily found, so people could perform reactions with it and identify, in this example, how many atoms there were in a given unit of a compound or an element, in the case of carbon. So if you take 12 grams of carbon, then you end up with this many atoms of carbon, right? 6.02 times 10 to the 23rd atoms of carbon. If you take 1 mole of aluminum, 1 mole of aluminum, how many grams do you need to get 1 mole of aluminum? How many grams do we need to get 1 mole of aluminum? 26.98? Right? Okay. So if we need 1 mole of aluminum, 26.98 grams is how many we need. How many atoms of aluminum would we have? How many atoms of aluminum? If we had 1 mole of aluminum, that's how many atoms of aluminum we have, right? So from that perspective, the mole is just a number. Like a dozen is a number. You can have a dozen eggs, which the word dozen was invented for eggs probably, right? I don't know. But you can also have a dozen dogs or a dozen pieces of paper, right? That all makes sense. You can have a mole of atoms and a mole of paper. If I had a mole of paper right here, the stack, how high would the stack be? What do you think? Yeah, it would go, what's that? Too high. That's right. Not 3 high or 4 high, but 2 high. It would go to the sun and back like 100 times, right? So a mole, 6.02 times 10 to the 23rd, is a huge, huge number of things. Okay? So when you have 12 grams of carbon, that's a mole of carbon. And this is the number of atoms of carbon that you have. Okay? Now this number here, we didn't choose the number. We chose the 12 for the 12 grams of carbon. And from that, we identified how many atoms of carbon there were in a 12-gram sample of carbon. All right? So, if I have 133.18 grams of aluminum chloride, how many units of AlCl3 do I have? I have 1 mole. Right? If I have that many grams, that's 1 mole. But how many units of this little business do I have? How many aluminum atoms do I have? I have this many aluminum atoms, right? Can you see that? Let's try that again with water, because water is a little bit clearer. See, if I have 18 grams of water, right? How many moles of water do I have? Well, I have 1 mole of water, right? How many molecules of water do I have? That's this crazy number, right? This crazy number is also on your calculator if you have a scientific calculator. There's a list of popular numbers, and this is one of them. So the mole ends up being a number, a number that has a name. What other numbers have names? Do you guys have any in mind? What other numbers do we have that have names? Pi is an example of a relationship between the diameter and a circumference of a circle. Any other numbers that have names? Okay. Like we say, I had a couple of hot dogs last night. A couple is supposed to mean how many? Two. What about several? I had several hot dogs last night. How many hot dogs did I have? So that's not a really good name. It doesn't help us really good, right? Okay, Euler's number, E. I don't know if you've heard of that one, another natural expression that occurs in nature. So the result is that this value down there can have units of grams per mole. How many grams you need to get a mole of a given material. Thus, you can perform chemistry, right? You can look at a chemical reaction, know what you're after, and you'll be able to predict how much you are going to get from combining these given amounts. All right? So, let's see here. This identification of how many grams you need to get one molecular unit or 1 mole of a material, like we mentioned, applies to not just elements but also compounds, right? Like water. So if I want to know how many grams I need for a given molecular unit of an ionic compound, all I have to do is add up all the atoms in that ionic compound, right? So how many grams of this material do I have to weigh out to get a mole of that material? What do we see there? What is this compound called? What's that? Something phosphate. Very good. You guys still have your periodic tables? You're going to need those over and over and over again. So, barium phosphate. Barium phosphate. Very good. So, how do we know how much we have to weigh out to get a formula unit or 1 mole of this material? We add together the mass necessary for 3 bromines, 2 phosphoruses. How many oxygens? 8? 8 oxygens. Is that right? So we add up all those values, and look, this is up here for you just in case you don't want to have to look back and forth between your periodic table and that, right? And then that'll tell us how many grams we need to get to weigh out 1 mole of this material. All right, so this is your chance. There it is. You've got your exercise machine there, and you got to do 5 lifts. If you don't do it, you miss the chance. But this is the chance. Get out your calculator, add this up. Make sure you have your exercise and know how to do it. If you're lost, you can raise your hand and I'll try to come give some aid. Yes, that's right. Add that to. Yeah, 31 times 2, right? 2 phosphoruses? Is that what you mean? Oh, just the P. So, right, first PO is 2 different elements, right? Yeah.
And then so that'd be 2 of those.
2 phosphoruses.
And that's 30.9.
2 of those 30.97s.
And then 4 of the oxygen, and that's 15.9.
I think it's 8 of the oxygens, right? Is there 8 of
Oh,
them?
yeah.
8 of them, yeah, that's
Okay.
right. So just add it all together. And if you get that one easy, go ahead and move to the next one. On that slide there. Anybody get an answer for this one? What's that? Oh, good. 601.9. Very good. So we added up all the different elements as mass, and that told us how many grams we need to weigh out to get 1 mole of that material. How about this compound? What's the name of this compound? What's that? Ammonium carbonate. Very good. You got to take these things seriously, guys. You're going to be in situations where you have to know the names of these compounds. What's more importantly is when they say something like, what's the molar mass of ammonium carbonate, you need to have the familiarity. And where are we going to get that familiarity right now? We have to use our periodic table. On the back side there, we have a list of polyatomic ions, right? So when we see the polyatomic ions that we don't know, you have to turn it over, find out their mass. Okay, did anybody add it all up for ammonium carbonate? How many nitrogens? 2. How many hydrogens? 8. So that's 28 plus 8, 36. So far we got 36, right? Then what? How many carbons? 1 carbon, that's 12, right? 36 plus 12, 48, plus 3 oxygens. Did I do that right? 96? Okay, 96. So does everybody see how we found that? What we had to do is we had to look at the chemical formula, find out how many different elements there were of each, and then if I had 2 nitrogens, I needed to add up 2 14s here. 8 hydrogens, I had to add up 8 of this 1.0079. 4. 1 carbon, I had to add in a 12.0107. 3 oxygens, I had to add in 3 of that 15.99. Oh, these are just that's a way to express digits that are not significant. So they're not positive about that value there. So you could use them if you want to, but yeah, we don't care about that many digits. All right. So that's how you identify how many grams are necessary to get a mole of a given compound. Okay? So then, given that a mole of carbon dioxide is 44 grams per mole, what's the mass of carbon dioxide if I have 1.55 moles? If I have 1.55 moles, how many grams of carbon dioxide do I get? Okay, so to answer this sort of problem, we want to use our method, right? We want to write an equal sign and then a line. What goes to the right of our equal sign? Grams of carbon dioxide. What goes to the top left here? 1.55 moles of carbon dioxide. Does everybody remember this? Okay, so when we have a problem like this one, the first thing we need to do is write an equal sign and draw a line, and then we have to write the units that we're after over here. You have to write not just grams, but grams of carbon dioxide. Be very clear. This gives you a goal to know where you're trying to go. Then you write the value in units of something they gave you in the problem. And then we have to work our units across until we get to our goal. Here, we see we have moles of carbon dioxide. So that helps me know that my conversion factor that's going to go here needs to have moles of carbon dioxide. Okay? What units should be up here? It should be grams of carbon dioxide, hopefully, because that's what we're trying to end with. Do I know how many grams of carbon dioxide there are in a mole of carbon dioxide? That's something else they gave me. There's 44 grams for every mole, 44.0098. Okay, I can see that the moles of carbon dioxide are going to cancel out, and I'm going to be left with grams of carbon dioxide. So this 1.55 times that value is what I need to do to answer this question. Okay? Next one. How many moles of carbon dioxide are there in 10 grams of carbon dioxide? So, I put an equal sign there. What units go to the right here? Moles of carbon dioxide. What units go to the top left here? Grams of carbon dioxide. What units go down here? Grams of carbon dioxide up here. Moles of carbon dioxide. How did I know that? How did I know that moles went on top and grams went on the bottom? Yeah, because I need to be able to cancel them out. 10 grams. 44 point whatever for every mole of carbon dioxide. So my answer, about 0.2 moles of carbon dioxide. Okay? You need to bring paper and pencil, and you need to work on these problems in class like this. If you don't, you're going to be in trouble. This is just the beginning, and a lot of these are intuitive. You don't need the method in your mind. But if you try to do it without the method, we get to problems that are not intuitive, and you have nothing then, right? If your mind has never been to that spot, you have nothing. But if you have some sort of method that should help you, then you should be able to get it. Okay, what mass in grams of, what's this compound's name? Calcium phosphate, very good. What mass in grams of calcium phosphate? What's that MM equals 310.1767? The molar mass. That's another way of expressing the grams necessary to get a mole of that material. So what mass in grams would a 3.2 mole sample have? All right? What do? We write an equal sign. We draw ourselves a line. We identify the units that we're looking for. To the right of the equal sign, we identify to the top left the units that we start with. All right? Now again, the solution to this one might be intuitive. You might say, oh, I know what I have to do. You just have to do this. But I want to see the setup so that we can answer questions that are more complex than this gradually. So, set it up. Show your partner how to set it up. I'll be right back. Okay, so the first thing you got to do is write the units that you're after over here. Write those units so that you can know. If you don't know where you're going, then when you get stuck, you're stuck. But if you have your units to the right so you know where you're heading, then it can save you. Okay, so equal sign, and to the right of the equal sign goes grams of, yeah, that stuff. That's right. And if you want to just write stuff, that's okay, but make sure you know what stuff you're talking about. Okay, good. So you got moles here, and that's how many moles there are per gram. So is that the answer then? Let's see here. 3.2 moles. Oh, is this true? There's 1 gram for every that many moles? Okay, good. We found the problem. Did you get it? So, what does this say here? So here we go. Equal sign, big long line. Give yourselves plenty of space. Grams of calcium phosphate, right? What do we start with up here? Moles. 3.2 moles of calcium phosphate. Right? Now you should be able to identify what units go down here and what units go up there. And then you know what kind of math you have to do to answer the question. Okay, so this looks great here, this part where you said grams of calcium phosphate, right?
Yes.
That's great. Now, 3.2 wasn't in units of grams per mole, was it? It's in just moles. So it's just 3.2 moles of calcium phosphate. Okay? And then down here, you have to have what units?
This line.
That's right, which is?
Moles of calcium.
Moles of calcium phosphate. Very good. What units have to be up here?
These lines.
That's right, grams of calcium phosphate. Very good. Now, what numbers go in there? What are the units on that number?
I'm not sure.
This is how many.
Moles.
No, this is how many grams you need to get 1 mole.
So it's put here.
Yeah, so that's how many grams you need to get 1 mole.
Okay.
Okay? Okay, so to the right of your equal sign goes what? Grams of calcium phosphate. I'm sorry that I told you that you could just say grams of stuff. It doesn't look like it's a good idea. You have to write calcium phosphate, okay? Change my ways, okay? So, grams of calcium phosphate here. Over here, what's the number they gave us? You don't always have to start with the same number. But 3.2 moles seems to stick out pretty well here. 3.2 moles of calcium phosphate. After I've gotten to this point, how many brain cells did that require?
Yes.
Yeah, it's very, very minimal, right? However, I've set myself up in such a way that it's very difficult to make any mistakes moving forward. Because the units down here have to be these ones to get rid of them. So I just write moles of calcium phosphate, PO4, right? Now up here, this is a little bit of brain cells, right? What goes up here? I would like it to be this. True? Because if it was, then my units would be done and I'd be finished with the problem. If I put that up there, Ca3PO4, 2, is there some information that goes along with this? There is. That looks like grams per mole. That looks like the molar mass of my calcium phosphate. And they told me it was 310.17. Where's the 310 go? Up here or down here? Okay. It's 310.17 grams for every mole. True? That's what molar mass means. So it looks like I have to take the 3.2, multiply by that value, and that'll give me my answer. Okay? So the answer, was either multiply them together, divide them by each other, which one. That's nice. But the answer was deceivable. You could perceivable, sorry, not deceivable. You could perceive it when you had your method set up. Okay. Where are we at? So let's try this again, okay? Here's another one. How many grams of hydrogen do I need to react with 0.7 moles of oxygen, if I want to form water? How many grams of hydrogen do I need to react with 0.7 moles of oxygen